the next part here is we want to find a whole bunch of information for curve sketching. So I'm going to rewrite. We have our answers here. This one's in factored and this one's in standard form. I'm going to rewrite them below. 3x minus 5. So I'll put a little factored over it because this will give us some info. F at x is equal to 3x minus 5, 2x minus 9. Okay, and then in standard form, we already found that info. It is also f at x is equal to 6x squared minus 37x plus 45. Those are big numbers there. Okay, let's move down. So we've got some good information. We need to do, they usually call this curve sketching. In other words, you got to get all these major points. You need to find x-intercepts, y-intercepts, vertex, axis of symmetry is technically, from all those points I've told you, you can find all those other things like optimal value, openings, up and down. So I talked about this a little before, and this actually comes in handy at this point here. Factored form technically has an A in front of it. They just don't commonly write it. And we have our R and our S, okay? In standard form, it is commonly written. You have an A, then you have x squared plus bx plus c. So this is where these letters come in handy because we can start to say what, instead of the number, because the numbers change with every quadratic we use, we can say which variable, like the c variable, what kind of graphing information does that give you? So we talked about briefly before, the c, that gives you a y-intercept in standard form, okay? So that's really good. We have a y-intercept. I'll start curve sketching here. We know one of our y-intercept is at positive 45. Whatever it is, it's at plus 45, that y-intercept. So we've got one part. That's really good. We need to get other stuff. Opening was a direction. Depending on the a value, whatever the a value is, that tells you which way it opens. So if it's positive, it opens up. And if it's negative, it opens downwards. In both cases, you'll notice 6 is positive. There's nothing here, but we just assume if there's no number, it's technically the value of 1 because 1 times anything doesn't change. But it's positive 1. So in both cases, it's positive. So you can actually look at either factored or standard form to figure that out. So what does that mean? That means we have something. Maybe it looks like this. Oh, that was a terrible sketch. Maybe it looks like this. We don't know. But it's opening upwards. We got that information. So that's good for us. Let me undo those two. So we're going to say opens up because it's positive. Another piece we want is x-intercepts. X-intercepts come from factored form, or at least it's the easiest to get from factored form, okay? We have two sets of brackets. An x-intercept is when y is equal to 0. So really what you're about to do is you're about to set this equation equal to 0. And remember I kind of mentioned how this is some number times some number. 0 is a really special number when we're multiplying. To get a 0, you have to multiply by a 0. You can't multiply by anything else in mathematics and get the number 0. So that means one of these brackets has to be equal to 0. Now we have a whole bunch of terms in them, but one of them's got to be 0. We just don't know which one. So we have these two sets of brackets with some variables in them. So what we're going to do from here is we're going to split them and we're going to solve for both. So in the first one, we get 0 is equal to 3x minus 5. And the other one, we get 0 is equal to 2x minus 9. We're trying to solve for 0. What could it be? At this point, we isolate. We're just trying to isolate for x. So negative 5 would go to the other side. It would become positive 5. And 3x, we have 3 on this side, and it's multiplied by x. So we'll divide both sides by 3. So in this case, x is equal to 5 over 3. Not a wonderfully nice number to work with. It's technically 1.66666. So one of our x-intercepts, I'll write it as a decimal. It's a little easier for us to graph, I guess. A computer would do a better job, but one of them's at 1.6-ish. Okay? The other one, we'll bring 9 to the other side. That becomes positive 9. We have 2, so we're going to divide both sides by 2. Again, not a whole number, but 9 divided by 2 is 4.5. So our other one is at 4.5. Again, I'm doing a rough sketch, our other x-intercept is there. So we have something that's going to look like this. Okay, so we have an x-intercept, we have a y-intercept. We need to find vertex. And again, vertex, from what we've done, we stay in factored form. So remember I talked about standard didn't give us a lot of graphing information? It really doesn't. It's the factor form that's important, and we're just going to keep working with those values. Now that I have two x-intercepts, I can find the axis of symmetry. So I'm going to call it AOS. And the little formula for it looks, everybody kind of writes it differently, but it's this concept. It's one x-intercept or one root plus the other one divided by 2. In other words, you're trying to find the middle of them or the average. For me, it's actually easier to work in fractions here because I'll get an exact value. Okay, are you more familiar with decimals, or if I work in fractions, is that?
Doesn't matter.
It doesn't matter? Okay, so if I have 5 over 3, it's going to get a little messy here. Over 2. Technically, this is all over 2. I have to find a common denominator. The reason I'm doing this is I'll get a more exact answer. I mean, you can always just use a calculator to do this, but if I double this, I get 10 over 6, and if I triple the other one, I get 27 over 6 over 2. That's going to give me 37 over 6 divided by 2 is actually equal to 37 over 6 times 2. Calculator might be a little nicer on this one. That's going to give me 74 over 6, whatever on earth that is. Hey, Google, what's 74 divided by 6?
The answer is approximately 12.333333.
Thank you. Okay. Okay. So this is the x value of the vertex. I'm going to go on a limb here and say your teacher for your test is probably going to give you some nicer values. But the x value of the vertex, okay, and technically the y value of the vertex, the x value is actually the same as the axis of symmetry. And the y value is either the max or the min value, depending which way it opens, okay? Because this opens up, this is a minimum value. If it had opened downwards, it would be a maximum. In other words, that's the bottom or the top. So this one's 12.3-ish. To find the y value, we actually have to plug it back into the equation for both of the x's and then find the y. So I'm going to, quite a bit to this question. We're going to plug in 12.3. So that's where this function notation comes in handy. And it's technically 3x minus 5 and 2x minus 5. Sorry, minus 9, I should say. We have to plug in 12.3 into these two x values. Okay, so we're replacing the x values with 12.3. We'll use a calculator. Technically, I would use my fractions again if I was doing this. Do you mind if I use the fractions? It'll give me a more exact answer. You can just use a calculator when you go through it. 74 over 6 minus 5. And 2 times 74 over 6 minus 9. Just use a calculator when you do this. I'm doing it this way because it'll help me speed through. This will become 74 over 3. This would be 15 over 3. I should have found a nicer question to use. Sorry, that's 2. I lied. That should be 2, and this should be 10 over 2. This should be 74 over 3, 27 over 3. Not nice values, I apologize. 64 over 2. That's, what the heck is that? Hey, Google, what's 74 minus 27?
The answer is 47.
Okay. Yeah, not nice values. 3, 2. This is 32 times something. Hey, Google, what's 47 divide 3?
The answer is approximately 15.666667.
Okay. So I multiply these numbers. I'm going to get a very large value. I'm assuming your teacher will give you a nicer equation probably to work with. Hey, Google, what's 32 times 15.6? You don't know? Okay. I can type it in here. 32 times 15.6. Whoa, almost 500. Let's say it's 500 here. Whoops. Go over here. Okay. I worked all of that out, but really what I wanted to do is I wanted to show you that that's the new y value. When you punch all that in, well, it's approximately 500-ish. So this vertex is 12.3 and about 500. Okay, write in 499.2, whatever the heck that is, when you go to do it. But I wanted to jump through this because that's also your optimal value is the minimum, okay? It's also the y value of the vertex. It's also the minimum. The x value is also the axis of symmetry. Technically, we've gone through all of the sketching. We have a y-intercept, a vertex, and our two x-intercepts. I think that's the last thing you needed. Let me just quickly check. Axis symmetry, optimal value. Yep, that's everything. Okay, so that's all of the stuff. That last step, unfortunately, took a while because I did it with fractions, but you can just type in with a calculator and get a relatively quick one.
Yeah.
But that's all of the steps to it. So there's quite a bit to it when you're going